So today we are going to discuss the various X-ray diffraction methods. In the previous lecture we have discussed what is the Bragg's law and Bragg's condition and Law's equations. So why making use of that laws, we will discuss the X-ray diffraction methods. So X-ray diffraction methods are basically used to solve two purposes. First is to determine the structure of crystal. So that means to determine the types of unit cell, its dimensions, its interplanar spacing, and another purpose is to study the X-ray spectroscopy. So to achieve both these motives, we make use of Bragg's law. So we have discussed what is Bragg's law. So Bragg's law basically is 2d sine theta is equal to n lambda. So this is the very important Bragg's law or Bragg's condition. So to fulfill the Bragg's law, both conditions of theta and this lambda should match, where d is the interplanar spacing, n is the order of reflection or order of scattering, and theta lambda is the wavelength of that X-ray. So since we know that sine theta cannot be greater than 1, sine theta less than equal to 1, so lambda is less than equal to 2d. So those planes, those interplanar planes, planes which satisfies this condition are known as Bragg's planes. I will use this terminology in between, so therefore it should be clear to you that what is Bragg planes. So this condition should be satisfied for these X-ray diffraction methods. So there are three types of X-ray diffraction method. First is Laue's method. This we are going to study in this lecture. Second is rotating crystal method. Third is powder method. So what is the main distinction between these three methods? But the basic laws that govern these methods is Bragg's law. So in the Law's method, that is lambda is varying and this theta is fixed. In this rotating crystal method, lambda is fixed and theta will vary, and this powder method, this lambda will be fixed and theta will vary. So this is the main distinctions. So to use this Bragg's law, we use different conditions for these different methods. So now we are going to discuss about the Law's method. So now the main condition for this Law's method, first is the incident X-ray is white X-ray. So I will later come on to this why this is called white X-ray. Second, the range of X-ray used is between 2 angstrom to 0.2 angstrom to 2 angstrom. And third is we will use single crystal. That means a small crystal which have dimension, that is 1 millimeter into 1 millimeter into 1 millimeter. So why I'm calling this as a white X-ray? Because the range of X-ray is between 0.2 angstrom to 2 angstrom. Therefore there will be in between 0.3 X-ray, 0.4 X-ray, 1 X-ray, 2 X-ray. So therefore there are different types of X-ray that will mixed up and that result into the white X-ray. So therefore this is known as X-ray, white X-ray. So now what will be the required setup? For Lawes method, first is collimeter, second is goniometer, third is your single crystal. So in single crystal we generally take zinc sulfide or NaCl, but in many cases zinc sulfide or zinc blende is considered. And fourth is photographic plate, on which the diffraction pattern will be obtained, or the Lawes spots will be obtained. So collimeter used to make this parallel X-rays beam. Goniometer is used to measure the angle. So goniometer is basically it is a device to measure the angle or vary the angle. It is clear from its name, gonio means angle. So this will be the required setup for the Lawes method. So this is Lawes method setup. So basically this is collimated beam of X-ray. What is the wavelength? The wavelength will be 0.22 angstrom. So you can say that this is inhomogeneous X-ray because it is varying from 0.0 to 2 angstrom. This is your single crystal zinc sulfide. This is your goniometer, so that you can measure the angle. You can set up the angle according to the direction of these X-ray. Generally these X-rays are made to fall or made to incident parallel perpendicular to the plane of this single crystal. So this is your diffracted beam. This is your photographic plate on which the diffraction pattern is obtained. Photographic plate. So generally the obtained diffraction pattern is kind of these spots. These spots are Lawes spots. So depending upon the symmetry or depending upon the geometrical structure, the geometrical spots are obtained on the photographic plates, and these spots are known as Lawes spots. So these Lawes spots basically form due to when this inhomogeneous X-ray is made to fall perpendicular on the Bragg planes of this single crystal. Due to the geometrical arrangement of these crystal, the geometrical pattern will be obtained on around the center of this incident beam. So therefore this is the explanation for the formation of Lawes spot. So what planes will satisfy this diffraction pattern? That condition will be, I have explained earlier, that is 2 sin theta, that is n lambda. Suppose your order of reflection, since if you consider order of reflection is 1, therefore this will be 2 sin theta is equal to lambda, or sin theta is less than equal to 1, so therefore lambda will be less than equal to 2d. So since in case of Lawes method or Lawes method experiment, the lambda is in between 0.20 angstrom to 2 angstrom. So since if you take that the higher limit for this lambda is equal to 2 angstroms, therefore this lambda should not be, it will always be less than 6 angstrom. If you put 2 angstrom, this will be this will be 4 angstrom. 4 angstrom. So generally if generally the higher limit for this wavelength of X-ray is 3 angstrom. So therefore generally this limit Bragg's condition for this wavelength will be 6 angstrom. So the major drawback of this Laue's method is that you cannot determine the crystal structure. Why we cannot determine this your crystal structure? Because we have seen that there is a range of wavelength for the X-ray. So if you consider that there are there are many X-rays which has the wavelength of this wavelength spread. So therefore if you see that if you consider a single plane, so therefore if you consider that many wavelengths of X-rays are made to incident on this plane, therefore if they reflect, so then they will interfere constructively, therefore they form a spot on the Laue spot, but this will not incorporate, or this will not give the information about this spacing or the types of unit cell. So therefore you cannot determine your X-ray crystal structure. This is the major drawback. And also another drawback, so if the wavelengths, if you take wavelength of X-ray high, that means 5 angstrom, so therefore your crystal structure, your diffraction pattern, your crystal structure cannot be resolved if the wavelengths are high. So your diffraction pattern, your Laue pattern cannot be resolved. And if wavelength of X-ray is low, if wavelength is low, so therefore angles will also be low. So therefore angle will be also below, so therefore angles will be very low, so the angles cannot be determined experimentally. These are the drawbacks. Now what are the benefits of using Laue's method? So by using the Laue's method we can determine the crystal symmetry. Crystal symmetry means, so if because we are having a geometrical Laue's patterns, so depending upon the symmetry of crystal, there will also be a geometrical symmetry in these Laue's spots. So for example, if the crystal under scrutiny has a 4-fold symmetry, therefore these Laue's spots will also have the fourfold symmetry. Fourfold symmetry means, so if you rotate this crystal four times, it will be identical. It will possess the identical geometrical shape. So that means fourfold symmetry. If I have six-fold symmetry particular crystal, these spots will have that particular six-fold symmetry. So therefore this is the major benefit of your Laue spots. So second, we can determine the imperfection in crystal. Imperfection means, so generally the planes are like this, straight parallel planes, but in case of deformation or imperfection, these planes will be like this. So this is straight plane with no imperfection. This is the plane with, this is perfect, this is with imperfection. Imperfections, that means the planes with the imperfection will be curvy. So therefore the diffraction pattern obtained on photographic plate will be also be according to this imperfection. So you can say that in case of imperfection you obtained a diffraction, you can obtain a diffraction streak in case of that crystal having imperfections. So you can determine the imperfection in the crystal by using the Laue's method. So this kind of phenomena which having a imperfection is known as, it is known as asterism. Asterism phenomena in which we can determine the imperfection of crystal by using the Laue's method of X-ray diffraction is known as asterism. This is very important. So these are the benefits of your Laue's method. So now to overcome these drawbacks of your Laue's method, we will discuss the another method of X-ray diffraction, that is known as rotating crystal method.